Today we are going over 9.2 graphing inverse variations. Alright, so graphing an inverse variation. The graph of the inverse variations has two parts. So we're going to be calling those two parts. Those are going to be called branches. Okay, so when we're looking at the branches, we're going to be looking at certain quadrants that they're in. So we're going to have two branches. So if we take a look here, it says draw a graph of y equals 6 over x. And we know that this is in the form of inverse variation because from last section, 9.1, we had y equals k over x was our inverse variation, where k is your constant of variation. Okay, so we're going to make a table of values, and we know that x cannot be 0, and that's because x is in the denominator, and we cannot have 0 in the denominator. So each part of the graph is called a branch. We just went over that. So we're going to be looking at making two branches. So if you'd like, we can just put it into two different charts here, so we know that we're going to have the positive branch and the negative branch. Okay, so if we look here, let's plug in some values of x, and since x cannot be 0, we'll first plug in points that are going to be above 0. For example, you can plug in a half for your x. So if I plug in a half here, I have 6 divided by a half. We know that when we are dividing fractions, we multiply by the reciprocal, and then we get a 12. Sorry about the writing, still working on this. That's a 12 though. You can read that. So that is equal to 12. Okay, so then we can move on. So we have 1 point already, a half, 12. We can now plug in the point 1. When I plug in the point 1, we have 6 divided by 1 is a 6. We can plug in the point 2. 6 divided by 2 is a 3. We can plug in 3. 6 divided by 3 is 2. We can plug in 6 and get 1. We can plug in 12. 6 divided by 12 is a half, and so on. You can keep going if you want. Okay, so this is going to be branch 1, and those are the positive values. Now we can plug in points that are to the left of 0, and that will be for branch 2. So we can plug in the same values for x here, except now they're going to be negative values. So we'll have negative 1/2, negative 1, negative 2, negative 3, negative 12. So when I do that, 6 divided by negative 1/2 is the same as 6 times negative 2, or negative 12. Again, we're going to get the same thing, just negated. 6 divided by negative 1 is a negative 6. 6 divided by negative 2 is a negative 3. 6 divided by negative 3 is a negative 2. 6 divided by negative 12 is a negative 1/2. Alright, so now we can graph those, and we know that since we cannot have x to be 0, that's going to be an asymptote. So we know that when we have x equal to 0, that's actually going to be on your y-axis, and we also are going to have another asymptote where you cannot have y equal to 0, so that's going to be on your x-axis, or y equals 0. And that is because we know that for these, this right here is x equals 0. This is an asymptote. And this is your y equals 0. And this is also an asymptote. Okay, so now we can go ahead and graph the other part. So we have our two branches. We have a half, 12, depending on how you want to go up by. You have 1, 6, so 1, 6, about right here. Okay, 2, 3, 3, 2, 12 a half, or we could have plugged in 6 and got 6, 1, and so on. And basically what this is going to look like, I already apologize that my graph is not going to be too good here. It's hard to graph on these. Not too bad. Okay, so that's branch 1, and now we're going to do the same thing for branch 2, which is just negated. And notice how my branch is approaching both of my asymptotes. So I'm going to go -1, -6, -2, -3, -3, -2, -6, -1, and again we're going to graph that. Oh, this one's not as good. Okay, you can also graph these on the Desmos app and it should come out a little bit more accurate. So that is graphing an inverse variation. Let's just put some things down here as well. If we notice, we can look at the domain and the range. The domain and the range are going to be all reals except x cannot be 0 and y cannot be 0. Alright, moving on. This one wants to know the domain of the function. We can graph this, y equals 16 over x. We're going to do that the same way. And then we should be able to notice what quadrants they're going to be in. So we should be able to remember that for the quadrants, we have quadrant 1, and then it's going counterclockwise, quadrant 2, 3, and 4. So if k is positive, it's going to, the branches are going to be in 1 and 3. 1 and in 3, just like the one we just graphed. Okay? So we can look at another one here, and we can compare graphs. So we're going to look a little bit more in detail of what the graphs are showing us. So we can graph both of these and we'll be able to determine the branches for this. And then we can also look at right here, these are going to be the points that are the closest to the origin, which is 0, 0, the origin. Okay, so we're going to look at those and we'll be able to find them. So let's start with 4 over x. So if we have 4 over x, then we can make our branches here, x and y, and we can plug in some values. So we could start with a half, 1, 2, 4, and so on. Okay, it's easier to plug in points that when you divide it, you'll get a whole number. That's why I didn't choose 3, but you could have chosen 3. So a half, so we have 4 divided by half, which is 4 times 2, or 8. We have 4 divided by 1 is a 4. 4 divided by 2 is 2. 4 divided by 4 is 1, and you can keep going if you want. Then you're going to have the same thing, but then they're going to be the negative ones. So you have a -1/2, -1, -2, and -4. When I plug those in, I'll get the same answers except negated. -4, -2, and -1. Okay, we also want to make sure that we have the closest points in our chart here. So the closest points for 4 over x is going to be the square root of k, the square root of k, and negative square root of k, negative square root of k. So your k here is 4. So if we do the square root of 4, the square root of 4, then we'll get 2, 2. And then if we do the negative square root of k, negative square root of k, we'll get -2, -2. And we have both of those points on our chart already. So we're all set. Okay, so we'll graph those. 1/2, 8, 1, 4. So let's see. 2, 4, 6, 8. 1/2, 8. Right here, about 1, 4. 2, 2. So right here, this is going to be the closest point to the origin for this branch. 2, 2. 4, 1. And so on. Make sure that when you graph these, you know that it looks like it's approaching your asymptotes, and when it's just in the form of k over x, then you know that your asymptotes are just the axes, or x equals 0 and y equals 0. For this one, we have -1/2, -8. So here we go. 2, 4, 6, 8, -1/2, -8 right there. -1, -4 right here. -2, -2, -4, -1, and so on. Okay, so we'll graph those also. Again, we know the closest point to the origin for this branch is -2, -2. And we got that because we know that the closest points are -square root of k, -square root of k. For this one, it was 2, 2. Okay, so that was 4 over x. Now we can do one for 9 over x. So again, we can plug in points. That's a y. Alright. Okay, so let's see here. We can plug in positive points. We could plug in 1. You could plug in 3. You could plug in 9, so on. So when we plug in 1, we get 9, 3, and 1. So we also want to make sure that we have the closest points, which will be the square root of 9, which is 3, 3. And we have that point right here, 3, 3. And we can also do the negative ones. So we have -1, -3, -9, and just negate the y's. -9, -3, -1. Okay, so we have 1, 9, 1, 9 up here. We have 3, 3. So this one is obviously not going to be as close to the origin because the closest point is 3, 3. And 9, 1. 9, 1, right here. Okay, and then we can sketch those in here. And here's one branch, the other branch, -3, -3 right here. We'll have -9, -1 over here, and -1, -9 over here, sketching that in. And there we go. Here's what they look like. So when you're comparing them, you want to say a couple of things when you're actually doing that. So if we want to compare them, we can look at, okay, let's compare them. We can say they're both in quadrants 1 and 3. Both have asymptotes of x equals 0 and y equals 0. We can also say that they both have reflections over the y equals x. They're both symmetric over y equals x and y equals -x. Over the line y equals x and y equals negative x. And then you can say what the closest points are for the other ones. Closest points for y equals 4 over x would be 2, 2, and negative 2, negative 2. And for your closest points for y equals 9 over x, you had 3, 3, and negative 3, negative 3. And that will do it. We could say that they have the same domain and range. The domain is going to be all reals. The domain is going to be all reals except for x cannot be 0, and that's for both of them. Alright, moving on. So this one, we kind of did one already. Okay, so if we take a look at when we have one as y equals negative 1 over x, that's going to be in quadrants 2 and 4. Okay, that's when your k is negative, if we're looking at y equals negative 1 over x. So let's go ahead and graph that one now. It's going to be similar to y equals 1 over x, but it will be in different quadrants. So we can graph those. Let's just take one of these graphs here that we didn't already use. Okay, so we're going to go ahead and graph that now, and we know what quadrant it's going to already be in. So alright, so again, we're going to plug in values that are positive, because we know that we can't plug in x to be 0, positive, and values that are negative. So we can plug in 1/6, we could plug in a 1, we can plug in, say, a 6, and so on. So when I do that, I'll have 1 or negative 1 divided by 1/6. That's going to be a negative 1 times, we multiply by their reciprocal, and we'll get a negative 6. When I plug in a 1, I get negative 1. Plug in a 6, and I get negative 1/6. So you can go ahead and graph that. And again, if you notice, it says what quadrants it's going to be in, 2 and 4. And if you look here, you're going to have a positive x and a negative y. So I have 1/6 and then negative 6. 2, 4, 6. About right here. And 1 negative 1. 1 negative 1 about right here. And this is now going to be your closest point to the origin. We have 6, negative 1/6. 6, negative 1/6, about right here. And then we can sketch that in. Oh, that one was kind of off. Alright. Not too good of a graph, but you guys get how it's supposed to be. Alright, and then x and y, we can plug in the negative version of all of these x's and get the same thing, just negated. So we have negative 1/6 and 6, 2, 4, and 6. Right here, we have negative 1, 1, and we have negative 6, 1, 6. Right here, and I'll attempt to sketch this. And again, we know the closest point. Sorry, my graphs are bad. Negative 1, 1. And these are the closest points. Alright, so now let's take a look at vertical asymptotes. So your vertical asymptotes, if we take a look here, we know that when we're looking at, for example, this first one, we know that we cannot have x cannot be 0 here because we cannot have 0 in your denominator. Okay, so if we have x equals 0, that's a vertical asymptote. So we'll draw in a vertical asymptote for that one. And we should know what that looks like. So we have x equals 0. We'll draw that in. And so we have x equals 0 right here. Oh, it's still a little bit off. Okay, and then we are going to, and then we also know that we have, we're going to have the same, the horizontal asymptote, okay, so we're still going to have the horizontal asymptote is still going to be y equals 0. Alright, so we could just write those in. This is x equals 0. And this is y equals 0 as our asymptotes. And then we can make a chart for that and go from there. Alright, so we have x and we have y. We already graphed 4 over x, and when we did that in the page up here, oh, not that one. Over here we plugged in a half, 1, 2, and 4. So you can plug that in. Half, 1, 2, and 4. We plug in a half. 4 times 2 is 8. 4, 2, and 1. And we can graph that. And then we'll have the negative of that as well. A half 8, 2, 4, 6, 8, half 8. Okay, 1, 4, 2, 2, which we know is our closest points to the origin, and 4, 1. Alright, so we know what that looks like already. Again, my branches are a little off. And then we'll do the negation of that, so negative a half, negative 8, 2, 4, 6, 8, negative half, negative 8, negative 1, negative 4, negative 2, negative 2, and 4, 1. 4, or negative 4, negative 1. Okay, we graph that. And the reason why we're graphing this again is because we're going to do a translation for this. Alright, so here it is. That's 4 over x, the inverse variation. Moving on, we're going to be looking at this one here. So if we take a look at the denominator here, we know that the denominator cannot be 0. So if we go ahead and solve for x here, we know x cannot be 2. So that means that this is going to be our new vertical asymptote. So let's go ahead and put that in here, and then it'll be easier to see what your asymptote is going to be looking at and how we're going to translate that. Okay, so we have x equals 2. So here's x equals 2. I'm going to just draw this in here, just like that. I still have the same horizontal asymptote of y equals 0. And now when I write in my vertical asymptote, we should be able to see, that we have x equals 2 is going to be your vertical asymptote, and therefore this is going 2 units to the right. You're shifting your 4 over x graph 2 units right. So everything is being moved 2 units to the right, and we know that if everything is being moved 2 units to the right, what you're doing is you're adding 2 to all of your x's. So we can actually make a new chart here. We're not changing the y, so we can leave those 8, 4, 2, and 1. This one will be 2.5, 3, because 1 plus 2 is 3, 2 plus 2 is 4, and 6. Okay, so we can go ahead and graph that. 2.5, 8, 2.5, 8 is right here. Or you could just count the boxes. 1, 2, 1, 2, and 1, 2. You could do the same for these as well. 1, 2, this is being moved over. 1, 2, and 1, 2, and then farther down, 1, 2. So again, it should still look like it's approaching your new asymptotes, which is x equals 2 and y equals 0. Okay, and then similarly, we know that for this one here, this is going to be similar. X plus 4 cannot equal 0, so therefore x cannot be negative 4, and therefore x equals 4 will be your new vertical asymptote, and therefore that means you're going 4 units left now. It's another type of translation. We've done these before with other types of translations. Okay, so now this is when we're going to have it where it's going to be changing the horizontal asymptote. So the horizontal asymptote is going to be, this one is going to be going 2 units up. So you go 2 units up, so therefore now instead of you having your horizontal asymptote at y equals 0, now we're going 2 units up, and therefore we're going to have y equals 2 is the new asymptote, horizontal asymptote for this one. And then for this one here, we'll have, this one will be going 4 units down. So y equals negative 4 will be your horizontal asymptote for this one. And then you would graph those. All right, moving on, we can kind of tie this all together here. We know that x equals b is going to be your vertical asymptote if it's in the denominator, and y equals c is going to be your horizontal asymptote if it's outside, and then we can go from there. So putting it all together, you're going to first draw in your asymptotes. So your asymptotes are going to be x equals 2 and y equals negative 3. And we'll first draw those in. So we'll draw those in here. Oops. And so we have x equals 2. Here is x equals 2 is right here. Okay. And y equals negative 3 is right here. And then we can write them in as well. So we have x equals 2, y equals negative 3. And then we can go ahead and, let me just move this over a little bit. There we go. Okay, so then we're going to graph that, and we can just still graph, we're still going to be graphing 1 over x, and then what you can do is you can use these as your new axes. So if we plug in x over y, x and y into 1 over x, and we plug in, let's say, 1/4 and a 1 and a 4. 1 divided by 1/4 is 4, 1 and 1/4. And then we'll graph that. So think of these as your new origin, or what you can do is you can graph the original 1 over x, and then this would mean to shift it 2 units to the right and 3 units down. So this is 2 right and 3 down. Okay, so we have 1/4, 4, 1/4, and 4, 1, 2, 3, 4. Thinking of these as my new axes. 1, 1, 4, 1/4. And this is one of the branches. The other one is just the negative of it. Negative 1/4, -4. Down here, -1, -1, 4, 1/4. Or -4 or -1/4. Okay, and then graphing these. And that's what the translation would look like. Alright, so finding the asymptotes and sketching the graph. So let's just say that, let's just find the asymptotes for this one. The asymptote would just be x equals, we would take this and set it equal to 0, the denominator, so x equals -7. And we know that if it's x equals a number, it's going to be a vertical asymptote, VA for vertical asymptote, and y equals -3 is your horizontal asymptote, HA for horizontal asymptote. Okay, if we have to actually write the equation, if it's x equals -2, that's going down here. So we have y equals 5 over, and then we're going to have x plus 2, because it's x minus a -2, or x plus 2. And then we have plus 3 on the outside, and that will be the equation for that. This one is saying that you're going to have it be 4 units left. So if we go 4 units left and 5 units up, 4 units left just means that you're going to have x equals -4, and 5 units up means y equals 5. So we'll have y equals -1 over x plus 4, and then plus 5 on the outside here. And that's all for today.